Livestock production is essential for food production and the economies of many countries. But like any productive industry, it also faces environmental challenges. One of them is methane emissions, a greenhouse gas that is naturally produced during the digestive process of cattle. Inside the rumen, certain types of microorganisms ferment the feed consumed by the animal, producing methane, which is released primarily through belching. Although this is a completely natural biological process for cattle, methane is a potent greenhouse gas once it reaches the atmosphere.
The sun's energy reaches the Earth as sunlight. The Earth's surface absorbs part of this energy and releases it as heat. Greenhouse gases trap some of this heat, keeping the planet warm enough to support life. But when their concentration increases, more heat is trapped, intensifying the greenhouse effect and contributing to global warming.
Methane also represents a loss of dietary energy. More efficient animals use nutrients more effectively for growth and maintenance. Because they require less feed to achieve the same performance, they generally produce less methane while becoming more efficient. So, how can we identify animals that are more feed efficient and produce less methane before they even enter production? The answer may lie in the animal's DNA. DNA is like an instruction manual that makes every animal unique. Small differences in this manual can make some animals naturally more feed efficient and produce less methane than others. And these genetic differences can be used to identify the best animals through genomic selection.
But what is genomic selection?
To understand how it works, imagine you're building a championship soccer team. Every young player has potential, but how do you know who will become a future star? One option is to wait years and evaluate their performance. But imagine having a tool that could predict their potential from an early age. Genomic selection works in much the same way.
We can predict an animal's genetic potential before its traits are fully expressed. This allows us to identify the best animals to become the parents of future generations.
In this study, we identified biologically important variants through genomic analyses and added them to a commercial genotyping panel. These variants improved genomic prediction accuracy by up to 5%. At first, this may seem like a small improvement, but when applied generation after generation, it can lead to meaningful gains over time. This means that accurately selecting animals that are more efficient, more productive, and produce less methane helps to make livestock production increasingly sustainable.
In this way, science, technology, and innovation work together to make livestock production more efficient, more productive, and more sustainable. Small improvements today can make a big difference for the future of our planet.